projects. In this video, we are going to explain about a project titled American Sign Language Detection using CNN and SVM. So now coming to the introduction part. American Sign Language, that is ASL, is a crucial means of communication for those with hearing impairments, promoting inclusiveness and accessibility. This research initiative presents an innovative method that merges convolutional neural network and support vector machine for recognizing and comprehending ASL signs. This advancement aims to enhance communication and interaction between deaf individuals and the wider community, making it more efficient and effective. So now coming to the objective part for this project. The goal of the study titled American Sign Language Detection using CNN and SVM encompass several primary intentions. First, here we have precise identification of ASL signs. The primary aim is to create a system capable of accurately detecting and identifying American Sign Language signs from video input. Second, here we have real-time implementation. The research strives to make ASL sign detection feasible for real-time communication. Achieving minimal processing delay is critical to enabling deaf individuals to engage in smooth and timely conversations through ASL interpretation technology. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hardest 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and matplotlib and Seaborn for visualization are important. Second, here we have exploring the dataset. Data exploration involves examining the dataset to gain insights into its structure, content, and quality. It helps you understand the data before processing and modeling. Then we have image processing using OpenCV plus Pillow. Reading the image, images are read and loaded into the environment. Then resizing the image. Images may be resized to a specific dimension for consistency. Then here we have using image data generator. Rescaling the image, images are normalized by rescaling pixel values. Then shear transformation. Applying a shear transformation to the images. Zooming the image, zooming images for the data augmentation. Horizontal flip, horizontally flipping the images for added variations. Reshaping the image, reshaping the images to a specific format for modeling. Next, we have data extraction from image. This step involves extracting relevant data or features from the images, which is essential for model training. Then we have splitting the data into train and test set. The data set is divided into two subsets, a training set and a testing set. The training set is used to build and train the models, while the testing set is used to evaluate their performance. Next, here we have model building. In this step, different machine learning models are constructed for specific tasks. The list includes convolutional neural network and support vector machine, decision tree, and a voting classifier that combines gradient boosting, XGBoost, and decision tree. Then here we have training the model with train and test and building the model. So the machine learning models are trained using the training data set and subsequently evaluated using the testing data to access their performance. Next, we have Flask framework with SQLite for sign up and sign in. The Flask web framework is integrated with an SQLite database to enable user registration and authentication. This setup is typically used for creating a web-based interface with secure access. User gives input. User provides input data, which could be images or other relevant data for prediction. The given input is pre-processed for prediction. The user provided input is pre-processed to ensure it is in the correct format for making the predictions. Then we have trained model is used for prediction for about image. The pre-processed input is then used with the trained machine learning models to make the predictions about the input data such as image classification. The last one here we had final outcome is displayed through front end. The results of the predictions are presented to the user through the front end of the web application, allowing users to view the outcomes and interact with the system. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as templates. So here we have a folder which is named as templates, and this templates folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Another folder which is named as static. This folder consists of files related to CSS, JavaScript, and Bootstrap files. Next here we have .ipynb file, which is a Python notebook file which contains a combination of code, graphs, and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next here we have app.py file, which likely contains information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content to be rendered in the HTML templates. Next here we have signer.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space. Type the cd command followed by a space and just paste the path over here and now hit the enter button. Now just type python app.py and then just hit the enter button. So after running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. Here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Just paste the link over here and now hit the enter button. So here you can see that this is our home page for the American Sign Language detection using SVM and SVM. These are the features that are deep learning, image processing and artificial intelligence. Here you can see that there is a button for sign up. Just click on this button. Enter your username, name, email ID, phone number and your password over here for doing the registration. I have already done the registration, so I am clicking on sign in button. So now just enter the username and the password over here which you have created while doing the registration. Simply click on sign in button. So here you can see that here it is asking for uploading the image to be classified. Just click on the choose file button and let me open the folder for uploading the images. So here you can see that we have to choose any one of the image from this. Suppose that I am choosing this image and now simply click on open button and click on upload button over here. By scrolling down below, here you can see the image which you have uploaded over here. It is detected that the American Sign Language is showing as 0. So depending upon the image you are providing over there, it will detect. Let's click on the try again button and try with some another image. Click on the choose file button. Suppose that I am choosing this folder and now click on this. Click on open button and click on upload. So by scrolling down below, here you can see that it is detecting as 8. So depending upon the image you are providing over there, it will detect the American Sign Language for the given image and it is detecting over as 8. So depending upon the image you are providing there, it will detect. Here you can see that there is a button for about. Just click on this button and here you can see that there are many different graphs where we have used many different algorithms, and based upon these algorithms we have got the accuracy, precision, recall, F1 score and many things. So here you can see that there is a button for sign out. By simply clicking on this button you can successfully log out with this. So now coming back to the conclusion part. The research conclusion regarding American Sign Language detection using CNN and SVM highlights the accomplishments in the realm of sign language interpretation technology and the possible positive influence on enhancing accessibility and communication for the deaf and hard of hearing community. In this investigation, we have effectively designed a system that integrates convolutional neural network for extracting features and support vector machines for classification. The outcome is precise and instantaneous detection of American Sign Language signs. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.